This conference will now be recorded.
Hello everyone. It seems that we have 26 participants at the moment. Well, everybody, welcome to the Virium Data Coaching webinar. My name is Jari Honkanen. I'm a project manager in MOVE Mobility Urban Values project in Virium Helsinki. And I have a pleasure to say that we have well-known data visualist Topi Tjukanov today here coaching us. First, couple practical things. Please keep your microphone silent during the presentations to avoid the background noise. You will have special slots for questions, and you can ask questions on the chat window. And also, please notice that this is a recorded webinar. We will make the recording available later, and the link can be found there in the registration page. And a word from our sponsor: please use your skills and participate MOVE Datathon 2020. I keep on posting these addresses on the chat window, and you can find them on the registration page as well. But now I will give stage to my colleague Sami, who will say a couple of words before we release Topi. He will explain something about transport data and Helsinki point of view.
Yeah.
Sami,
hi everyone. A few words why we are here. There's to start with, there's a lot of data needs with the cities. New data coming up every day, basically. New types of information that cities are not really able to even manage, because it's new type of information that we didn't have previously. We need to have new ways of dealing with that data. Hence, visualization is one really key way of doing that. So we want to learn more. Another point here why we are doing this webinar especially is that we did we had this European project called MUV. You just saw a little bit about that. And the point of that is that we need to look into ways of making people choose differently, choose a more sustainable transport mode. And in order to do that, people need something more. Why would they do that? And one part of that would be via incentives or gamification. So this project has trialed and experience with gamification in order to push people to choose something differently, choose sustainable mode over personal car, for example. And that will create different new type of information to get us as a city to learn about when do people choose different type of transport mode, for example, to understand what are the reasons behind these decisions. That's something new for cities, and again, we need better ways to understand that and to cope with that kind of new types of data on top of the existing data of traffic volumes and travel times that we are dealing with in day-to-day basis everywhere with all our cities. So that's the setting, and then for my part and then Helsinki's part, we are really keen to learn more. And then, like Jari said, we're really happy to have Topi as one of the mobility data visualization gurus here locally. So it's with that, I'm really looking forward to learning much more during this next couple of hours. But with that, Topi, off you go.
Thanks a lot. I'm already said that I'm not gonna share my cam because there's not much to see. I'll have the slides to show instead. Let's go.
Yes. Yes, we can see your screen now.
Okie dokie. So like you already heard, I have few parts in the presentation where I have separately put that you can ask questions in the chat. So please do. So this won't be just me talking for 1.5 or 2 hours. Let's see how long this takes. I'll try to collect stuff that I would like to see, stuff that I would like to hear or know. So I really hope that this is useful for people, because I'm assuming now that there are people online with very different technical skills, very different interests. So I've tried to collect something for everyone. Let's see how that works out. But I will have I will go through some tools that I'm using, some examples, mainly my own examples of what I've done, and some others too. And then I'll go through some tools some datasets, examples of datasets that I've worked with. But also a few words from my sponsor, because I do this for a living. I work in a company called GISPO, and we do things with open source software and open data. So all the tools that I will be talking about here, or most of the tools that I will be talking about here, will be open source tools, and most of the data sets that I will be talking about will be open source or open data sets. So in that sense, there's like everyone can easily try them out or take them into use. That's one of the points here. What I do at GISPO, I've worked with, don't worry, I have only a few corporate slides here. We work quite a lot with the Finnish public sector, with ministries, municipalities, different government officials. And I personally do here, I work as a GIS specialist. My background is in business and in geography, mostly in geography. Because I've studied geography and it's my profession, most of my examples will be containing, this will be highly GIS focused presentation or webinar. And before I joined GISPO, I was working as a freelancer doing data visualization work and GIS stuff. And I was also working at the Ministry of the Environment not so long ago. Maybe some of you have seen my work on Twitter, or maybe not, doesn't matter, but I will be showing some of the examples I've posted there. I post my visualizations and other stuff there too quite actively. So you might have seen something from there. Yeah, okay, that was the corporate, the sponsoring part. So about visualizing movement data. When I started collecting the slides, I realized how huge this topic is, but still I've tried to cover it as well as I could. But I started from a point of view, because I've gone through the visualization stuff that I've done personally. I've noticed that I work mostly with visualization, visualizing transportation data. First of all, I personally think that it's easy to make it look pretty good, and it's because it's dynamic. It's nice to visualize, and it's not the easiest type of data to visualize, and that's why I quite like to analyze and visualize it. And thirdly, I think when you're visualizing movement data, like something like GPS tracks of people, you can see something from the built environment about the things that something about you're kind of aware of. I hope this makes sense. But if you get the idea that at least that's how I personally feel, that visualizing movement and transportation data can reveal something really new. This is an old phrase that you hear from people working with spatial data or GIS data or in the GIS scene. It's like a marketing phrase that people selling spatial services and other type of things usually say that. Did you know that 80% of all your data is spatial? It's kind of an empty phrase, really, when you start thinking about it. But then if you think about movement data, the type of data that we are now talking about, I would say that I'm not selling anything here, but I would say that movement data is always spatial data because we're talking about movement. So you're moving from point A to point B. So there's always place involved. And that's why, because there's place involved, that means that it happens in space. So it's spatial data. So that's why it's logical for when visualizing movement data, it's logical to use spatial tools and the techniques used in spatial data visualization. So that comes back to GIS and geography. So maybe that's why it's so logical for me to always go back to transportation data, because it's so logical to visualize on a map or also with graphs, as you will see later on. But I'd say that understanding basics of GIS spatial data visualization is very important. So this is like I took like really basic stuff because I thought that it's nice to get everyone involved. If this feels really simple for you, don't worry. Then, but I hope that there's also something new for someone. So when I'm talking about spatial data or geographic information, it's data that happens somewhere. So it has an X coordinate, Y coordinate, and maybe even a Z. Well, it has always a Z, but maybe a meaningful Z too. Typically, in geographic information, geometries have been divided to points, lines, and polygons. And then to this vector data, certain attributes are connected. And they are objects that basically are in empty space, and they have they can have, through relations, they can have many attributes connected. But you don't have to visualize all the attributes. Second main category of geographic information is raster data. From the point of view of movement data, raster data is not as common, and it's mainly we are talking about vector data when we are talking about movement data and geographic information. This is like GIS 101, where it all starts every time, like points, lines, and polygons. Then vector geometry types, the points, lines, and polygons. Point reference data is usually, like, for example, GPS devices. Those produce points. They can be points of interest. So it has X and a Y. Then the polygons, they can be representing municipalities or other type of administrative areas, some type of grid-based data, any type of you might hear a term called geofence that's used in that's relevant to movement data visualizations. And as you can see from the structure, points and lines are also structured. Lines and polygons are also structured basically from points. And then the third main category, lines and networks, very important in movement because we're talking about road network and connections. So these are really, now we're somewhat on an abstract level, but these are usually I like to start from this if someone is coming from, let's say, from web development perspective and hasn't been someone with a background in geography. This is pretty basic stuff, and someone who has been working with GIS data, this is pretty basic stuff. But someone from web dev or something else, this might be something that you have to first understand when working with spatial data. The attribute information that I mentioned, it's descriptive information for those geometries, and that descriptive information can be names, any type of values, and like in other data too, the types of the attribute information can be of different types. Then something specific to movement data. So when I said that the basic types are usually points, lines, and polygons, when we're talking about movement, quite often the raw movement data is coming from GPS devices. So it's or GPS devices or something really similar. So a logical way, or maybe not the most logical way, but a typical way for the data to be stored is as points. So you have first point, second point, third point, and these have attributes like timestamps and some IDs connected to those. But then from an analysis point of view, storing the data in this way becomes really difficult to handle tracks and handle complex data sets. So if you have relatively ordinary questions, for example, if I start my give me all the journeys, let's imagine a case where you would have a data set with 1 billion GPS points, and then you would like to answer a question that's give me all the journeys that start from this area and end in this area within this time frame. In a typical GIS case, those would be stored as points and maybe as lines, but the actual query would be really complex and really intensive in terms of computing. So that's why movement data is also, besides normal points and lines, movement data is also stored quite often as trajectories. So for example, in PostGIS, that geometry type can be line string M. So basically you have a line, but then you have an M value as a timestamp. But that's just one example. But something to remember, trajectories are a better way to store very large data sets than just points and lines. Then, like, that part also already touched this issue, but this is a webinar or coaching session about data visualization, but data visualization shouldn't be done without data analysis. So I think a strange way, or maybe even might be wrong to say incorrect way, is to just collect data and just throw it all out there just to visualize everything that you have. Well, this is not movement data, but this is what I'm talking about. So as a Finn, I understand that this might be correct, this type of visualization of all the saunas in Finland. But what does this really tell you? Not much. It basically tells where people live, because every Finn almost has a sauna in their home. So just collecting data and plotting it on a map isn't really, that's data visualization, but it doesn't tell much anything to the user. So I would say that the most important part of the visualization happens before you start thinking about any type of front-end solution or what colors would look nice. First, you have to think, what are you visualizing? What are you trying to say? What's meaningful inside your data set? So if you just throw everything on a map, it's usually it's more than a finished product. Is I would say that it's a method of exploratory data analysis that I do it quite a lot, and sometimes I post on Twitter the things that the data is looking like in the middle of exploratory data analysis. So I do it, but very rarely is that a good end product from analysis. So if you put too much data on a map, usually it's firstly it's difficult for the user to understand what's meaningful here, what I'm trying to say, and then secondly also it's difficult. It brings complexity in terms of technology. If you have way too much data thrown in your application, then it just becomes slow. So that's simple, but that's just how it goes. So not trying to visualize everything, not trying to throw all the data on a map at once. First, I say what not to do, and then I show an example of how I've done everything wrong. Or then I can say that actually this is just exploratory data analysis. So this is data from Helsinki public transportation system. There's an open API. I will have a link and talk more about this later on, but there's basically like a live API of all the locations of all the buses, all the trams, all the trains at all times. So I had a small personal project lately where I was collecting data from the live feed, and I was visualizing it in very different and exploratory ways. One of the ideas that I had was to actually collect the data from the live feed and then analyze when there would be heavy snowfall. I wanted to analyze, do like a spatial and a temporal analysis on how it affected the snowfall affected public transportation system. But as all the Finns here know, we didn't have basically any snow this year in Helsinki, so I ended up just having a lot of data and no question to answer to. But still, it was interesting to collect the data and visualize the data. You might be thinking, what are different colors saying here? What are they representing? Nothing. They are just random colors, and each track has a random color. So basically, you can distinguish one bus line, and it has one random color. And you might be also thinking, why are some paths following the roads and some are going directly from A to B? But that is because of the GPS data quality. On a general level, it's really good. The API is really nice and works well. But of course, because there are thousands of GPS devices on different vehicles. That means that all of them can't work perfectly at all times. So that's why the lines you see here aren't following the roads perfectly. But yeah, these ended up looking more like public transportation modern artworks rather than telling anything meaningful. Here's another explanation from, this is from, like the source says, this is from Anita Graser. I have quite a lot of materials from her in the presentation. You should definitely check out her website if you're interested in a more scientific approach to movement data visualization. But this is also from her, this description on data visualization, and basically the same thing that I was trying to say. I would say that too often people end up just gonna get the pointer. Yes. Now you should see. Yeah. Too often people just end up working with the globe here and then collecting some data sets and then visualizing it and then publishing it back. But as most of you who are working with data, maybe daily or even every now and then, you know that most of the time is spent with data processing and cleaning, and then seeing how it looks, and then collecting some more data, going back to data cleaning, then doing some confirmations on what are you really trying to say. Does it really look how it should? Does it answer your original question? And then only after then you should be doing your final visualizations and your products from that data set. So I must say that I'm myself too eager to publish the visualizations, but to really produce something meaningful out of it, you should spend a lot of time with processing and cleaning and going back and forth, unfortunately. Then more on the theoretical part, more, let's say, more on the GIS 101, because we are talking about spatial data. We should also be looking at spatial relationships. The first law of geography is really simple. Everything is related to everything, but if something is closer to another thing, it's probably more related to that. That's my own wording of the same thing. So with spatial relationships, you can also, by understanding spatial relationships, you can easily produce new types of data. So a classic example is that you have two completely different data sets, like I would have the GPS points from a mobile phone, and then from another data source I would have cafe locations, and then with a simple analysis I could answer a question: what's the nearest cafe at each point in time? So, and spatial relations it's like in my example, quite often when talking about spatial relations, the question is what's the closest or what's the furthest. But if you're working with movement data, it's good to understand that you can also, with spatial relations, you can also look at directions or distance, directions, or proximity. You can look at topologic relations. Is this point on this line? Is this point inside this line? Is this point outside of this area? And so forth. You can look at hierarchical relations of different data sets and so forth. So this is really, once again, basic GIS, but something you should, when you're collecting, and especially when you're collecting large amounts of data, you should stop and think, what does this mean? Spatial relations are typically described with this model called DE9IM, intersection model. So if this looks confusing, don't be worried. Basically, the idea is that you can answer, you have two objects, like here you have two polygons, A and a B, and with this model you can analyze how the two objects are related to each other. So basically the same thing that I was explaining with a point, and an example with movement data is that all the companies offering scooters, e-scooters in the city, they have a specific area where you're allowed to use the scooters, and specific areas where you definitely can't ride the scooters. So, but basically they have a spatial relation. They're looking at spatial relations. So the scooter is a point, and then they have predefined area where the person can drive, and then if the point is outside of their area, something will be done. And then, of course, if you have different types of geometries rather than just points and polygons, it can be more and more complex. One term that I wanted to raise also here is that's important to understand is topology. It's expressing the relationships between connected objects, and the most best way to understand the meaning of topology is if you think about a road network. That's a road network or administrative areas. The topology of administrative areas should be such that there aren't any gaps inside those administrative areas. And the topology of a road network should be so that because it's constructed from small line segments. So if there are gaps, even minor gaps inside with those between those line segments, that means that the topology isn't intact. It isn't correct. So that means that if you would try to compute a route from point A to point B, that means that the network, it can't form a network, and so it can't form a route from between those 2 points if your network isn't complete. So, and understanding topology is something that's typical case that I encounter in my work when working with different types of data sets is that for the human eye, the data might seem okay, but then when you're doing topological analysis for the data, you realize that there are really minor gaps in the data, and it doesn't work because for the computer to be able to calculate areas correctly and process them correctly, you have to have the topology of the data correct. Then once again, like from theoretical perspective, things that you should be aware of, and especially when you're working with large data sets, is accuracy and scale. So the more accurate your data is, in terms of let's say that you have, in the simplest form, you might have a point data set that has x and y coordinates, and if your data set has if the coordinates have 10 decimals, for one single point it doesn't really make a difference. But then again, if you're working with a data set where you have billions of points, then all of a sudden your bill from Amazon might be a bit bigger, and you might run out of disk space, and your queries all of a sudden take a bit longer to execute. And also understanding the concept of scale is something that it takes a while, but then after working with geospatial data for a while, you start to understand that when does it make sense to have really accurate, for example, again, administrative areas are one good example. So you might have really generalized data sets that you can work with, can use for visualization, but then when you're doing something, automatic calculations or topological analysis, for example, you need highly accurate, the most accurate data set that you can find. Or another example is a road network. So if I'm making just a visualization, a map with the Finnish road network, I don't need the full DigiRoad dataset, which is around 10 gigabytes. Instead, it's enough to have a few megabyte road dataset that's highly generalized, and then if I zoom in, it doesn't look correct, but on a more generalized scale, it works just as fine. So like I already said, do not store too detailed information. And the more data you have, the more space you will need to store it. This is an XKCD explanation of basically the same thing. And understanding that if you have latitude and longitude data, quite often, like a good rule of thumb is that in most cases, 4 decimals is enough, or 5. Like if you see here, if you're working with 5 decimals, you're already on a scale where you're pointing a specific person inside a room. And then there are some tools that have around 50. If you're storing latitude and longitude information, the default is 15 decimals. So at that scale, we are already on a pretty like atom scale. So quite often, if you're storing, for example, GPS data, even the original measurement isn't as accurate as the data that you stored. It just basically you end up with not quite random numbers, but really useless data set. So this is something that you should take into account when collecting data. So that's like the most theoretical part of today. So now I'm gonna take a sip of water so I can continue and hopefully see 1 or 2 or maybe 3 questions in the chat, because I see that there are people online, like most of you haven't left yet, so I hope that I get to answer at least something. So if you have any kind of questions about like this theoretical approach, maybe you will have more questions after I present some tools, but happy to answer already now.
Yes, you can send the chat messages to all, or to organizers, or to privately, directly just to Topi, which might be, of course, that then Topi really needs to take a look at them. So you choose, but happy to have them for visible to all if possible.
But if you don't have any questions, that's fine too. But like Sami said, you can send also the questions directly to me. I will see them pretty easily. Okay, so then on to the next part, tools. Like I said, I work with GIS data. I work with open source GIS data. So here's basically the stack, the tool stack that I mostly work with. And any kind of idea how familiar this looks to you, so I'm going to explain it briefly, very briefly. The most common pieces of the puzzle that I work with are Postgres database and its spatial extension, PostGIS. Then as a tool, a desktop tool, and for visualization, I use QGIS. I will talk more about QGIS in a minute. And then to publish datasets, APIs, mostly use GeoServer. And then on the front-end side, Leaflet and OpenLayers are the most typical ones to like JavaScript libraries for spatial data. So these rely on common components like GL and geos. So and this is not like the full open source GIS stack, but this is something that I mostly work with, and we GISPO as a company. So yeah, that was all of my PowerPoint animation skills to queue going around. That was to highlight that I'm not now going to talk more about QGIS. So QGIS is a desktop application, open source desktop application, and here's how it looks. So basically, you have a map canvas, and on the left you have data sources, and on the right you have different kind of operations that you can do with the data. So this is the tool that I most work with in my work, and also for fun. It has been around for almost 20 years. It was previously, if you ever hear the term quantum GIS, it's the same thing as QGIS nowadays. Actually, that should say QGIS 1.10 is the current long-term release, but anyhow, this is it's now in the version 3.10 or 3.12. It's really actively developed. It has around, it depends on how you calculate, but it has around 30 core developers. And it's an open source tool, so its development is mostly driven by different kind of sponsors and funding, and quite a lot of just pure volunteer development too. Because it's open source, no one knows how many people use it, but one typical way to evaluate this with Google Trends, and this compares QGIS to a few other desktop GIS software, which is ArcMap and MapInfo. Either this is telling that people can't use QGIS and Google more, or then this tells that the QGIS is gaining popularity quite a lot, which seems to be true, at least from my perspective. I feel like there's more and more people around the project, more and more organizations using it, and for very different kind of purposes, and a lot of things happening around QGIS. So I believe that this chart is somewhat accurate. Something about the technical background of QGIS. The source is built with C++, and it's based on Qt. But there is also a Python API inside QGIS, which is quite nice because it makes it extendable. There are a lot of different QGIS plugins, like I will show a few today, and it's supported on multiple different operating systems. So I personally use it on both Windows and Linux, and it works really well on both, and also on OS X and on Mac and Android too. Then about the data formats that QGIS supports, because QGIS is heavily dependent on the GL/OGR library, that means that it supports almost every type of spatial data format. I say almost every type of spatial data format, but that's I would say that that's one of the best aspects of QGIS, that it's you can read and write almost all types of data formats. One example of QGIS plugins. I think someone has a mic on. There are some. Okay. Yeah. No. Thanks. Yeah. There. One tool that I've been mostly using for making spatial data and movement data visualizations is the QGIS Time Manager. I would say it's described as fun and simple, because basically it takes in, like QGIS takes in vector data that has timestamps, and then you can easily animate them and then output frames or video or whatever. I have written a Medium blog post about how to use the Time Manager, and you can also check the GitHub page for some examples. Here's one that I already did, a few years back already with Time Manager, and this type of animation is a typical example of what I've done with it. So what this is showing is there's a live API from Finnish Transportation Agency that shows the ship locations on the Baltic Sea. And so I collected some of that data and then exported it to, I think it was a geo package or something, some vector format, and then animated it with Time Manager. So basically I had a lot of points with timestamps, and then Time Manager just has this type of play button, and you can go back and forth, and then you can export it to a GIF. Here the colors of the points are representing the ships original color, so under which flag they are. So the purple ships are Finnish ships, and the orange ships are Estonian ships, and then as you can see there are a lot of other colors too. Another way to visualize movement data with QGIS is QGIS Atlas. Basically, it's meant for automated map making. That means that you can easily produce different type of reports with QGIS Atlas, and QGIS Atlas is not like Time Manager. Atlas is not a plugin. So when you're using Atlas, it has more options, but at the same time it's slightly more complex than using just Time Manager. And I don't think anyone was originally thinking to visualize movement data with QGIS Atlas, but at least I have done some visualizations pretty nicely. And just like with Time Manager, you can take some data in, visualize it, and then export the frames, and then build something out of the frames. So here's one thing I did. This is not the final visualization. I did and there's also I've also written a tutorial about how to use. If you Google that, you can find the Medium post that I've written. So I have done an animation with train locations, and in a way that basically the map follows train based on real GPS locations. This was also done in a similar way as the Time Manager animation. So I had collected beforehand data and then visualized it with Atlas. So if someone hasn't used QGIS, this like typically I describe it in a way that what it can do. So I think one of the best features about QGIS is that it can read and write basically all spatial data formats, and it can handle them really well. Also, really large data sets, it can read very efficiently. But then quite a lot of the data that you use with QGIS is static files. You can use also APIs, but it's not a tool for it's not the optimal tool for live data analysis and visualization. I think one of the highlights of QGIS is that you can do very nice visualizations, and then if you I think nice feature is also that there is the Python API that I mentioned. So you can extend QGIS, but you can work very well without actually writing any type of code ever. Then if you haven't used QGIS and you're thinking, so can it do everything? One thing that it doesn't do really well is produce interactive visualizations, because if you think about it from a technical perspective, you want to do an interactive visualization, you need to host it somewhere, you need to have a server. So QGIS is a desktop software. So you can export, there is a plugin called QGIS to Web that you can export web maps to, but QGIS is not, by default, it's not a tool for interactive visualizations. And it can't make you breakfast. Then a bit more tools. So this was like the QGIS part, but that's not all. So like I already earlier mentioned, Anita Graser, she has done a lot of work with movement data, and she had this kind of a division for different open source stacks. And this was not purely for visualizations, this was also for more leaning towards the analysis side. So I already mentioned QGIS and PostGIS. That's the most common that people use. That's the combination that I mostly use. Then Anita Graser herself has done a lot of work with Jupyter notebooks and a Python library called Moving Pandas. So Moving Pandas is based on the popular Pandas Python library, but it's just more suitable for example, trajectory management and so forth. And Jupyter notebooks is a easy way to share code and run other people's codes on the browser or wherever. And then another option that she has described is GeoMesa with Spark. So those are, I hate hype words like AI and machine learning and big data, but those are big data tools. So when you're talking about terabyte scale data sets, you should look into the GeoMesa, for example. MobilityDB is another way if you have a technology stack based on Postgres and PostGIS. It's dependent based on those. And like I said earlier, that in the beginning, that with traditional GIS tools, it's hard to answer questions like how to manage large spatial temporal data sets and answer questions like what if my journey starts here and ends there, like how many journeys have a similar pattern. So MobilityDB has a better way to handle trajectory data sets, and I haven't used it myself. It has been on my list of things to do for a long time, but it's just a tool that comes up and I couldn't leave it out without mentioning. And I already mentioned Moving Pandas. So it's based on the really common data science library Pandas, but just like with MobilityDB for PostGIS, Moving Pandas is more for movement datasets. Then something I also wanted to take here as an example is because maybe you've already noticed that I personally I'm not a front-end developer. I don't find that nearly as interesting as working with the data. But I wanted to bring one example of a front-end solution that you can use, an open source one. So Kepler GL is an open source tool, an open source project by Uber, which is really actively developed. It's built on Mapbox GL and Deck GL, and if you're using Jupyter notebooks, you can also put Kepler GL inside Jupyter notebooks. And the nice thing there is that you can build a really simple web apps with Kepler, because you don't need a backend because all the data is stored on the client. But I would consider as a downside is that it's quite picky when it comes to data sources. So you have to have them in a specific GeoJSON or CSV format. But still, few downsides. But in general, I had pretty good experiences with it. This is a sneak peek to a project that we are currently doing at GISPO with Kepler GL. We're visualizing all types of data sets, but this is one data set that we're visualizing. Once again, it's the live train API, and basically you can, if you give Kepler a CSV file with timestamps in a specific format, you can do these types of interactive visualizations relatively easily. So it has movement dataset is one of the basic visualization types inside Kepler. So if you're interested in something like this, you should check it out. And then, although I'm not a front-end developer, I've also been able to produce something completely on my own with Kepler. I did a visualization about the city bike trips in the Helsinki region. So basically, I think this was data from August. I'm not going to open the interactive visualization because I'm sure that everything will break if I open it. But basically, this shows direct trips from point A to point B, where the bike trip started and where it ended, and the thickness of the line is representing how many trips were taken. Then a set of tools that you might also need when visualizing movement data is routing tools and routing APIs, because you probably want to find out the shortest route from A to point B for different purposes. And few that I've taken here and I've used myself are PG routing, which is once again based on Postgres and PostGIS. If you want to do the routing in your own database, then one I've used quite a bit is Grasshopper. That's a Java-based open source routing engine, and then there's also OSRM, which is C++ based. Both Grasshopper and OSRM are easy to set up with OpenStreetMap data, and relatively easy to set up also with your own network data. But I've used, for example, Grasshopper, and I think both are offered also as services, but those are open source solutions that you can host on your own. But there are also proprietary APIs, of course, of finding the easiest way from point A to point B. Here's one example of what I've built with Grasshopper. Well, the visualization was done with QGIS. Let's say that the data analysis part was done with Grasshopper and Python, and those were basically the tools. So what this is showing is that I did some of you maybe have seen the original inspiration for this online already a few years back. It was called Roads to Rome project. So that's where I got the idea. I wanted to reproduce it, and then eventually I was able to reproduce it. So the idea was that I wanted to visualize all the points from all the optimal routes from all the US counties to the geographic center of the US. So I think this visualization also is showing what I mentioned at the beginning, how movement data can reveal some kind of hidden patterns that you're in some way aware of, but then still it's surprising when you see it on a map and visualized. Here's something I did. I don't think this looks as fancy, but still, I did the same type of thing with the city bike data that I showed earlier. So I had, like previously I showed, I had direct lines from point A to point B. So with Grasshopper, I did an analysis where I calculated for each of the trips. I calculated the optimal route by bike through the road network. So, but especially with city bikes, we know that people aren't always definitely not taking the optimal route. So not maybe telling the truth, but still it was interesting to see how it looks. It reveals a few spatial patterns here and in Otaniemi region and around the Helsinki city center, from where people move to city and so forth. Then a few more points about tools. If you're working with spatial, if you want to work with spatial data and you're more familiar with Python or R, one of the basic libraries that you should look into is GDAL/OGR, because like I already said, those basically enable you to read and write all types of data formats. Then if you're doing something to modify the data, you probably should look into Shapely and GeoPandas. GDAL is really good, especially with raster data. Bokeh works for data visualization, and then the deeper you go, the less you need specified spatial tools, but rather something like NumPy or Scikit. I don't know much about R, so I'm not going to tell anything more than a few packages that I've seen people use and Google people use. Yeah, leafleting R is good also. I got a comment from there. Yeah, good. Now already a few comments appeared, so it's again good time for questions before the third part, the last part of the webinar. I'm gonna again sip some water and then answer questions. Yeah, firstly, in order, any thoughts on using GTFS data? Yes, I've had few experiments with GTFS data, and it's really nice. It's a really good way to share public transportation, like schedule data and so forth. But the few experiences that I've had is that although it is somewhat a standard, it still seems to be that the times that I've tried it, the contents have been very, very different on different GTFS datasets. So nice that there is a standard, and actually, when I think from a tool perspective, I think how I would work with GTFS data is I would maybe import it to PostGIS or something, but yeah, haven't used it too much. Yeah, another comment about instead of using points with time attributes, we should prefer trajectories. Yeah, it's just an idea that I think there isn't a definite limit after which you should move from storing your data from points and lines to trajectories, but I think that is a consideration when you have, to put it simple, definitely when you're on a billion point scale, you should pay more attention on how you store the data. But like an example of trajectories is again, you store it as, for example, as a line string M, and then you can more easily answer complex or different types of spatial temporal questions. So you can look at, for example, MobilityDB, the type of questions that MobilityDB answers. So that might be helpful. My favorite visualization lately, and why, is Jari asking. Well, good that you asked, Jari. This is not a planted question, but next off I'm going to show a few visualizations, and they're going to be a few of my favorites too. And of course, some of my own stuff, but few other my favorites. Then we're moving to visualization examples. When talking about movement, I think closely tied concept to movement is accessibility, which is really complex as a term and a concept. And I think accessibility is a thing that hasn't been yet completely solved, the problem on how to visualize. And I think this is also something that Sami touched in the beginning, that complex, that for example, if I would choose on what's the best way from moving from my house to the city, well, now of course I'm not moving anywhere, especially not with public transportation, but still it's really hard to compare different methods, and or let's put it that way, that it's really hard to visualize really the differences between different public transportation methods. There are different ways on visualizing accessibility, but I don't personally think that any one of those is really perfect. I've done a lot of visualizations with isochrones, mainly because they look nice. And isochrones are a curve of equal travel time. So basically, you have a starting point, and isochrone shows where you can reach from that point. And another thing I've done when I've tried to visualize accessibility is with animations. So I have examples of both. This is once again, thing I did already a few years back, but it has I compared different European capitals. I had each capital presented here as the city center as a starting point, and then I had 1 hour by car. I wanted to see how far you can drive in 1 hour by car from the city center, and to make them comparable, each city has the white circle around the center. So basically, you can, of course, this tells something about geography, because in Helsinki you can't move from south from the city center because there's sea and so forth. But it also tells you interesting things about the structure of the city, because, for example, London has ring roads around it. So if you're starting from the city center, of course the traffic is also really bad, but it takes you time to get to the ring roads. So I personally think that this is a nice way to compare. And also the isochrones that's also another example of a thing that you, when you see it, you understand it, but you can't see it in the built environment. Another isochrone example, really simple visualization style, is that I estimated, I think this was this 3 hours or 2 hours the limit, but basically I had each European capital as a starting point, and then on the hatched area you can reach a European capital inside time limit. I think it was 2 hours. Let's agree that it's 2 hours. So once again, I'm using isochrones here, but they look very different. And I also took this here because I quite often the visualizations that I do, either they have way too much stuff, or then I have tried to keep them pretty simple, like this one. A third isochrone example is what I did with I did this 5.5 hours isochrones for a few different European cities, and the visualization style I took from an old map. It was from the 19th century, like a European. It was that was also a travel time map from Paris. So I took the color scale, the color scheme from that map, and took it to like with modern data. This was again, I did the isochrone with it was done with Here API. So there's a plugin in QGIS that you can connect to the Here API, and with Here API you can do, I think it was 250,000 queries with the free tier, so quite a lot. So I collected the data with QGIS from Here API, and then did the visualization inside QGIS. I'm going to answer a few questions now, because otherwise I forget, and it's nice to answer now. The source of data for generating isochrones, yeah, I mentioned that it's Here API, and then another question about what's the output given from Here API. So here it's a REST API, so basically it outputs your coordinates in a string, but the plugin for QGIS, actually now I'm not 100% sure if Here API could also output GeoJSONs nowadays, but at least when you use it through QGIS, basically you get it as a memory layer, and then from QGIS you can export it with just right click to any sort of format, so CSV, GeoPackage, shapefile, or whatever. But it's a REST API. Yeah. It's a REST API, maybe giving GeoJSONs, JSON at least. And another example, this is starting to answer to the question, my favorite visualizations lately. So this is from the UK, a guy called Alastair Ray, who has done a lot of visualizations with QGIS too. So he did this type of 45-minute cities in the UK, where he compared different UK cities and how many people you can reach with public transport from the city center in 45 minutes. And I think from a visualization perspective, it's a really nice effect when you can see the city structure in the area that you can reach, but nothing else. So I think this is a really nice example. So a lot of isochrone examples, but then I mentioned also that animations are one way to visualize accessibility. So I've done a few of these. These are done with the dataset is called MetroAccess. It's originally produced by University of Helsinki. So it's like a grid data set that you can select a starting point, and then you know to each other grid cell how long does it take with by foot, by bike, or by car, or by public transportation. So here I have a single starting point, which is in the city. I think this is from the harbor. The pink is a car, the yellow is a bicycle, and the blue color is public transport. So This is done with 100% with QGIS and with QGIS Time Manager. Here's another example. Similar idea that if a journey starts from a single point at rush hour, how long does it take to reach different places? So this might be visually, there might be too much stuff, might be hard to reach, might be hard to remember which place was reached first, but still I think this creates quite a nice effect. Then I took another topic besides accessibility, for examples, visualizing a change in movement. This is definitely the least appealing looking visualization in the whole presentation. It's made by me, so this is. But I wanted to take this because this is very topical at the moment. I compared the amount of cars in Helsinki region. This was last week and the week before, and just wanted to take this as an example because you can also visualize movement data with other tools rather than just maps or graphs, and different type of charts are perfectly valid. So what this is telling is that on the bottom you see the hour of day, and then on the here you see how many cars were measured at each point. So this is because of the lockdown currently happening. Still people moving. I haven't checked actually the latest data, but I should. Here's a, let's say, a similar idea, but with larger data sets and better visuals. So same kind of idea that how many cars are currently moving and compared to a normal day. So historical average is the red one, and the gray is during last 7 days. I took this from Twitter from John Byrne Murdoch. You should definitely check him out. He's doing graphics for Financial Times, and if you've seen any of the coronavirus visualizations, he's behind those. Really cool stuff. So this is I think this is quite an impressive visualization to show the change. There was a question, which tool was used to estimate travel times by public transport in that animation? It was the dataset. It's called Metrop Access, and the tool was QGIS. So you can access the Metrop Access data also through a site called maple.fi, like I had it here. On the bottom, I have the site here. So you can access the data, you can export it as CSVs. You need a bit of data wrangling, but then the tool is just QGIS. Then this is something I really, now I'm going to take the risk and open the link. Okay, it wasn't worth it, but this is something that you should definitely look into. This is by a Dutch, I think he's a data designer, or what is Jan Willem Tulp's real title, but really crazy data visualization about the movement on the Dutch railways. And Then another example of my latest favorites is by a company called Teralytics. They visualized mobile phone data in Italy and how it changed during the crisis. So no moving points on the map, but basically just showing how much has a bit in the same way as the charts that I showed in the same way shows the difference in how people are not moving anywhere. So that's really cool too. So let's get an animation in the browser. And the last topic, I've already mentioned some data sources for movement data, but I wanted to highlight a few. Uber has a project called Uber Movement. It's not open in all the cities, and I personally think that Uber could share much more of their data. But even this is quite nice. Basically, it's a service where they offer. You can analyze rush hours with Uber Movement because you can choose a district within a city, and then the data tells based on Uber locations, based on the Uber data collected from Uber drivers, on how long does it take to each the other districts, and how much does it differ from an average. Then a Finnish example where I'm very lucky as a person doing data visualizations in Finland, because we have, for example, Digitraffic, which is the ship data I earlier showed was from Digitraffic, and also the train data that I showed. So we have those kinds of open APIs from publicly available in Finland. So Digitraffic has road traffic from public sources, railway and marine. Then Digitransit. So we have Digitraffic and Digitransit. Digitransit is then from there you can find for Helsinki region you can find free routing APIs, you can find public transportation information, and you can find, for example, the live public transportation locations that I showed earlier. Really nice service too. So this is another example of what I've done with the Digitransit API. So there you have the green points are trains, the yellows are metro, and the purple is trams, and the blues are buses. So I'd like to do this type of visualizations. I've done this quite a bit, and I like to do this type of. This is a good example, in my opinion, about exploratory data visualization, where there's something really interesting data set that then I see what I can build out of it. Okay, so those were my slides. So hopefully you have comments or questions, or if you don't, that's also fine too. You can see my email there. You can reach me on Twitter, or you can send me an email. But if you have any kind of comments or anything, I'm happy to hear.
Well, Topi, while waiting for more questions, one thing would be that, let's say let's assume I'm a beginner, not with any GIS background or geography studies behind me, but I'm convinced I like to do this. Where would be the best place to start with? Is there For Dummies book or something?
YouTube, of course. Everything starts with, all the questions nowadays is answered with YouTube, and so is this. So what I would do is that I would go to YouTube and check like QGIS for absolute beginners.
Okay.
So because like I presented, QGIS is maybe the most, I think starting to learning Python from scratch to do data visualization might be an overkill. So that's why I would recommend using some point and click tools like QGIS. So without any type of background, I would recommend going to YouTube and checking QGIS for absolute beginners.
Sure.
Yeah, nice to see a lot of questions. So I'll start answering from top. Yeah, there's a compliment for the Financial Times visualization. I totally agree. It's really nice and easy to look at. And it's also interpolating movement data on a shape. Any tools? I would use there. I would use Postgres and PostGIS. So basically, I would store the, if I'm understanding the question correctly. So I'm assuming that you have a shape, for example, a road segment, and you want to interpolate a location on that road segment. So there is a pre-made function inside PostGIS to interpolate a point with a certain distance on a line segment. So for interpolation movement data on a shape, I would say that's PostGIS and Postgres. Challenging visualizations that I haven't managed to do yet. Yes, a lot of them. And I think visualizing the accessibility in a way that you could easily compare and comprehend the options of and say that the cost of different transportation modes, the total cost, like in terms of time and CO2 and everything, like visualizing that is something that I haven't seen done well, and I would like to do something better with that myself. Then there's a question, will you do the 30 days map challenge this year? Yes, I will. If someone isn't familiar, in November I had this, well, I didn't have it, I just accidentally started it, this 30-day map challenge where a map was created with different theme each day of the month in November. So yes, I will. I already have a 30-day map challenge 2020 GitHub repo open, so pull requests and issues welcome. I will post more on Twitter, at least when November closes. Yeah, glad to hear that it was a good. You found it a good overview. Really nice to get positive feedback. Yeah, there's another question about undergraduate degree in GIS, but totally new to data visualization. Where should I start with? So if you have an undergrad in GIS, you have maybe sometimes worked with a GIS desktop software. So maybe that one might be a good place to start. So see what kind of data visualizations you can build with that, and start from basics. Don't put the bar too high in the beginning. Just you can consider a map as a map is a data visualization, and GIS tools can make maps. So first step might be good to make really beautiful looking maps. That's what I do. That's what I try to do, at least. Yeah, good points. Python, Shapely library in Python has probably a function, yeah, for interpolation. So yeah, if your interpolation is Python. If Python is part of your tool stack, then checking out Shapely is a good option. And then what would I need? Sami asked me directly, what would I need in terms of new tools? Nothing, because I think I'm already in trouble because there are so many tools that I don't have time to try out. So a message to all the open source developers: stop developing, because I don't have time to check out everything. Just joke. It's really cool to have all kinds of tools available. Yeah, and then thanks for the feedback. Really nice to get positive feedback. And then Marco is asking any new ideas on mobility datasets that aren't yet open. Yeah, thanks Marco, because I was asking the CityBug dataset earlier, and eventually it got opened up, which was really great. I think the type of datasets that I would want to see open it's a problematic question because they're already breaching privacy, because the more accurate the original dataset is, the more questions it can answer. That's how I feel. Just now, I think from mobility perspective, because we have the CityBike trips open, we have a live API for the public transportation, so it's really hard to say. I think we're in a pretty good place. Oh yes, Sami, good point. E-scooters data, definitely. That's something I almost forgot, that the city is full of e-scooters, and I haven't seen. Actually, I think it was one of those datasets that I tried to get at some point. I contacted the company, one of the companies, and they didn't respond at all. But yes, that's a really good point. If I would get my hands on e-scooters, that would be very interesting, because they don't follow the same kind of patterns as the city bikes, and they have they have internal GPSs, so they all the tracks can be followed. That would be interesting. Yeah, really nice to get some questions and kind of like discussion, although only I'm talking. Yeah, thanks Outi for the feedback. Really, I will keep spamming stuff on Twitter. Then a question about the COVID-19 and what kind of visualizations will come out of this. I think, let's see if I'll take a risk and let's see if this is working. At least it's loading. So I think, well, might be that my presentation and this GoToMeeting is eating up my internet, but I think there are already a few really nice visualizations, if you can say nice, but let's say impressive visualizations about COVID-19. Now, especially everyone, when this staying at home, this kind of change in movement is a really big topic to visualize, and how well people are following the rules and so forth. Yeah, John Murdoch's, he has done great work with the charts that he does. Yeah, and true that he uses ggplot. He was actually, I know that he was supposed to come to Finland for a presentation this year, but of course now it's not happening. But there's a lot of discussion on his charts on Twitter, but I personally like them quite a lot. Okay, any more comments, or should we draw it to a close? But like I said, here's my email. I'm on Twitter. My DMs are somewhat open. My email is open. So any ideas, just reach out. But a big thanks from my side. It was really nice to talk about a topic that I personally like.
All right. Thanks everyone for tuning in. Thanks really a lot, Topi, about this like fascinating stuff, really. Yes, do check out the Datathon, that the MOVE project that basically be sponsoring this webinar is having within next few weeks. It's free. There's even a little bit of price there, as I understand. So now that you are all kind of enthusiastic about doing something with that, take a look at that as well.
Yeah, thank you, Topi.
Yeah.
Thank you, audience, and well, I guess that was it, and take care.
Thank you. Bye-bye.
Bye.